We've got a pretty good idea at this point how we are going to get people from the Earth to Mars. Elon Musk is going to fly us there in a giant stainless steel Starship rocket, and that is going to be amazing. But one big question that even Elon Musk still seems to be pretty vague on so far is, what are we going to do when we get there? What is Mars Base Alpha going to look like? Where do we sleep? Where do we work? And how does all of this infrastructure get built? It's a pretty interesting idea to consider. What would a house on Mars be like? Well, let's talk about it. This is the space race. So obviously there are some pretty significant limitations that we have to work inside of when we're talking about what can realistically be built on an extraterrestrial planet. As cool as it would be to have everything made from shiny steel with giant glass domes, that's probably not going to pan out for the short term. Maybe 100 years from now, we might have some total recall level infrastructure, but in the meantime, we have to be very considerate of size and weight limitations. The Starship vehicle that we'll be using has a weight capacity of 100 metric tons. And that's contained in a cargo fairing that offers up about 1,000 cubic meters of usable volume. The fairing is basically the entire top half of the ship, 9 meters across at the widest and 26 meters high. So we can definitely fit a lot of stuff in there, but available space is going to start going fast when we start accounting for all of the robots, vehicles, solar power generators, batteries, water tanks, food stores, and science equipment that is going to have to go along for the ride. We also need to consider the environmental factors. Mars is cold in most places most of the time. There are occasionally some warm spots, but the average temperature value is sitting around negative 63 degrees Celsius. So whatever we live inside must be insulated. Then there is the issue of atmospheric pressure. Mars has next to no air pressure on its surface, and humans can't live in such a low-pressure environment. We would basically explode just very slowly. It would be a horrible, bloody mess. So wherever we live must be pressurized, and the structure has to resist the massive difference in pressure between the inside and outside. And on top of all that is cosmic radiation. The Earth has a magnetic core that extends a giant magnetic field around the planet. That magnetism is able to bounce back radiation from the sun and is one of the key factors that allows life to exist on our planet. Mars does not have a magnetic core. It's just a big dead rock in space. So no magnetic field means the surface is bombarded by cosmic radiation, and we don't know what the long-term effects of that exposure would be on human beings. According to Marvel Comics, it might give you superpowers, but more than likely you'll just get space cancer. So our Martian base has to protect against radiation as well, which is not hard. We don't need a special material. It just has to be a thick, dense barrier. But of course, that doesn't work so well with having to pack all of our stuff into the limited space available in our starships. So, does that mean we just give up on Mars? Hell no. It just means that some very smart people are going to have to figure out alternative building methods that can work autonomously on an alien planet. And luckily for us, those smart folks are already hard at work solving the problem, and the solutions range from simple and straightforward to bizarre to straight up disgusting. So here's what we've figured out so far. So one of the classic solutions to living on the frozen radioactive ball that is Mars has always been that maybe we could live under the ground. We'd definitely be well insulated and protected down there, but then there are a ton of logistical challenges that come along with it. How do we dig the tunnels? Is the Martian surface even suitable for tunneling? What's the point of being on Mars if you just live under the ground the whole time? Well, the International Design Practice Hassel, in partnership with engineering firm Eckersley O'Callaghan, have an idea to create an artificial cave on the surface of Mars that would present all of the benefits of being underground without any of the troubles that it brings along. The idea is to 3D print a giant shell using autonomous robots and the Martian soil, or regolith. The robots first set about gathering materials from the surface of Mars. Rocks, dust, soil, everything they can scoop up is all brought together and processed into a printable medium that will act like a paste when it's heated, but cool to be solid as rock. With this, the robots will print a shell layer by layer. They're essentially building a hollowed out mound. Then, when the human settlers arrive, we would deploy the interior of the base, which would be a series of collapsible inflatable modules. So the habitat itself would essentially just be a bunch of balloons, which would make them very easy to pack and transport. The modules themselves wouldn't be very sturdy, but it wouldn't matter because the giant shell of solid rock will be doing all of the heavy lifting when it comes to providing protection from the Martian elements. Next up, let's talk about shrooms. Yeah, this one is pretty trippy. But the very smart people at the Myco-Architecture project out of NASA's Ames Research Center in California have this idea that we could grow our habitat on Mars using fungi. We could live in a fungus house. Specifically, they are talking about the unseen underground threads that make up the main part of the fungus known as mycelia. Lynn Rothschild, the principal investigator on the early stage project, explains it like this. Quote, "Right now, traditional habitat designs for Mars are like a turtle, carrying our homes with us on our backs, a reliable plan but with huge energy costs. Instead, we can harness mycelia to grow these habitats ourselves when we get there." Ultimately, the project envisions a future where human explorers can bring a compact habitat built out of lightweight material with dormant fungi that will last on long journeys to places like Mars. Upon arrival, by unfolding the basic structure and simply adding water, the fungi will be able to grow around that framework into a fully functional human habitat, all while being safely contained within the habitat to avoid contaminating the Martian environment. Basically, the idea is that the fungus dome would have an outer layer of frozen water that would act as our insulator and radiation barrier. Then there is a middle layer of bacteria that can take that water and photosynthesize using the outside light that shines through the icy layer to produce oxygen for astronauts and nutrients for the final layer of mycelia that makes up the structure of the dome. As a proof of concept, the researchers have made this fungus stool, which looks absolutely horrifying, like an image from John Carpenter's The Thing, and will be in my nightmares forever, so now yours too. But it does seem to prove that you can build stuff out of fungus, which is pretty cool. But this is just the start. Mycelia could be used for water filtration and biomining systems that can extract minerals from wastewater, as well as bioluminescent lighting, humidity regulation, and even self-generating habitats capable of healing themselves. Okay, if you thought the mushroom thing was weird, then this is about to get straight up disgusting. What if we build our Martian housing with human blood and pee? This sounds like an idea hatched by the guy who directed Human Centipede, but I assure you, it's legit. Human blood and urine mixed with dirt to make a kind of bioconcrete. Researchers from the University of Manchester made the proposal as a means to greatly reduce the cost and increase the speed of construction for future off-world colonies. In a paper published in Materials Today Bio, they detail how extraterrestrial dust can be mixed with the blood, urine, and other bodily fluids of astronauts to build walls that would protect them from radiation and meteor strikes. In their study, the University of Manchester researchers demonstrated how human serum albumin, a common protein from blood plasma and urine, could be used as a binding agent for extraterrestrial dust, turning it into a material stronger than ordinary concrete. The researchers state that the blood plasma protein required for the material could be safely extracted from astronauts multiple times a week using an existing procedure similar to blood donation. Of course, that begs the question, is it safe to constantly extract blood from people who are already trying to deal with the incredibly stressful task of establishing the first ever human colony on an alien planet? One would probably assume not, and of course, the other major issue here is that unlike with the 3D printing, we can't pre-build our blood and pee houses in advance of humans arriving. Also, it really seems like the 3D printing folks have figured out how to turn Martian soil into a buildable material without soaking it in human bodily fluids. So it seems questionable, but I am not a researcher at the University of Manchester, so what do I know? In laboratory tests run by the University of Manchester team, the blood plasma protein infused material, dubbed Astrocrete, showed compressive strengths as high as 25 megapascals. This is about the same strength as traditional concrete. However, by adding urea, a biological waste product excreted through urine, sweat, and tears, the researchers found that they could increase the strength of Astrocrete by over 300%. The resulting material showed a compressive strength of close to 40 megapascals, making it much stronger than traditional concrete. So the piss is the real secret, which is promising because that's at least a lot easier to get out than blood. The scientists calculated with a crew of 6 astronauts, more than a half-ton of Astrocrete could be produced over the course of a 2-year mission on Mars. In theory, each crew member could provide the resources to expand a habitat enough to house an additional crew member, meaning that housing could be doubled with every crewed mission to Mars. So you can produce enough blood and pee yourself to mix with dirt and build a whole apartment. That's not what you came to this video to learn, but now you know. You're welcome. Please subscribe. Also, let us know which Martian colony you would prefer to live in: the balloon cave, the fungus house, or the blood and pee apartment. This should be an interesting comment section. Also, if you've seen any other approaches to building houses on Mars, let us know about those as well. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.